Welcome back to episode 11 of the Gray Files, where we peel back the layers of technology, economics, data science, and even the human condition itself, all in an effort to try and understand this vast and often perplexing world we live in. I'm your host, Erika Barker, and tonight we're diving into a mystery that will fundamentally change how you see the invisible forces shaping your daily life. In episodes 7, 8, and 9, I gave you an idea of how powerful a data scientist can be. So let me paint you a picture of what that power looks like when the lights go out and the real work begins. It's 3:47 a.m. in a nondescript office building in Palo Alto. Most of the world is asleep, but Sarah Chin is wide awake, staring at patterns emerging from what most people would see as digital chaos. 3 monitors glow in the darkness, displaying cascading numbers, shifting graphs, and algorithmic outputs that look like something from a sci-fi thriller. But this isn't science fiction. This is the hidden reality of our data-driven world. Sarah isn't just crunching numbers. She's architecting the invisible infrastructure that will decide whether your mortgage gets approved tomorrow morning, which medical treatment protocol gets recommended to your next doctor's visit, and even who appears in your dating app queue this weekend. She doesn't wear a uniform or carry credentials that announce her authority. Yet, she wields more influence over your daily decisions than most elected officials ever will. This is the mystery we're unraveling tonight. How did we arrive at a world where algorithms have become the new power structures, and data scientists like Sarah are their largely invisible architects? How did these modern alchemists learn to transform raw data information into digital gold? And why do most of us have no idea they even exist? The numbers tell a story that should unsettle anyone paying attention. Harvard Business Review famously dubbed it the sexiest job of the 21st century. But that catchy headline masks a profound and somewhat disturbing truth. These people have become the puppet masters of our digital age, pulling strings most of us can't even see. When Netflix seems to read your mind, suggesting exactly the show you didn't know you wanted to watch, that's not magic. That's Sarah and thousands like her, building recommendation engines that analyze your viewing patterns, compare them to millions of similar users, and predict your preference with unsettling accuracy. When Amazon ships products to warehouses near you before you've even thought to buy them, that's predictive analytics powered by data scientists who understand your purchasing patterns better than you understand them yourself. But here's where our investigation takes a darker turn, into territory that most people aren't supposed to see. While the rest of us were distracted by arguments over Facebook privacy settings and targeted ads, companies like Palantir Technologies were quietly building what intelligence agencies call God's eye view of complex situations. Palantir isn't your typical Silicon Valley startup, as we learned in episode 7 of the Gray Files. It was founded by Peter Thiel and Alex Karp. It doesn't chase consumer eyeballs or social media engagement. Instead, Palantir's data scientists work in the shadows, helping the CIA track terrorist networks, assisting ICE in immigration enforcement, enabling police departments to predict crime patterns, and allowing corporations to map entire markets with surgical precision. The company's very name comes from Tolkien's Lord of the Rings. The Palantir were crystal balls that allowed the users to see across vast distances and communicate with other seeing stones. It's not subtle symbolism. Palantir's founders understood something that most of us are only beginning to grasp. In the information age, the ability to sort signal from noise isn't just valuable, it's the ultimate superpower. Their data scientists aren't just employees. They're the architects of intelligence infrastructure, building systems that can identify patterns across millions of data points, predict behavior with disturbing accuracy, and influence outcomes at a scale that would make George Orwell's Big Brother look like amateur hour. This represents a fundamental shift in how power operates. We're living through what historians might one day call the data revolution, a transformation as profound as the Industrial Revolution, but happening largely out of sight. Political power once came from controlling land, then from controlling capital, then from controlling information. Today, power comes from controlling the algorithms that process that information. And the people who build those algorithms are data scientists. The profession itself is morphing at breakneck speed, like watching evolution in fast forward. What started as a relatively straightforward role, part mathematician, part programmer, has exploded into a constellation of specialized functions. Today's data scientist must be part ethicist, part storyteller, part psychologist. They need to understand not just algorithms, but human nature, business strategy, and the unintended consequences of their creations. The field is undergoing what biologists would call adaptive radiation, a single species splitting into multiple specialized variants to fill different ecological niches. We now have machine learning engineers to handle deployment, data engineers to manage infrastructure, AI researchers pushing theoretical boundaries, product analysts translating insights into business strategy, and ethics officers trying to prevent algorithmic disasters. This explosion isn't accidental. It's the natural evolution of a field that emerged from a simple but staggering observation. The world now generates more data in 2 days than humanity created in all of recorded history up to 2003. Every click, swipe, purchase, search, step, heartbeat, and sleeping pattern creates digital breadcrumbs. Data scientists are the ones following that trail. And what they're discovering is reshaping everything from medicine to marketing, from education to entertainment, from crime fighting to national security. But like all powerful technologies, this one has a bloodline, a hidden history that sketches back much further than most people realize. Part 1: The Ancient Bloodline. The first true data scientist was probably a man most people have never heard of: John Graunt, working in 17th century London during the Plague Years. While others fled the city or prayed for divine intervention, Graunt did something revolutionary and slightly obsessive. He counted. Grant analyzed what London authorities called the Bills of Mortality, weekly death records that most people viewed as grim bureaucratic necessities. But Grant saw something else: patterns hiding in the data. He discovered that plague deaths weren't random, they followed predictable trends. More people died in certain neighborhoods at certain times of year, from certain causes. The data revealed hidden structures and what appeared to be chaos. Graunt wasn't just counting corpses. He was building the foundation of epidemiology and proving that statistical analysis could reveal truths invisible to casual observation. His work saved countless lives by helping authorities understand how diseases spread and where to focus their limited resources. Then came Thomas Bayes, a Presbyterian minister who stumbled upon one of the most profound insights in the history of human reasoning. Bayes figured out how to mathematically update probability estimates as new evidence arrived, a concept so fundamental that it now powers everything from spam filters to medical diagnostics to the recommendation engines that run our digital lives. Every time an AI system gets smarter by learning from new data, every time a search engine refines its results based on user behavior, every time a medical AI adjusts its diagnostic confidence based on test results, they're all applying Bayes' 300-year-old insight about how rational beings should update their beliefs when confronted with new information. Carl Friedrich Gauss gave us the method of least squares, the mathematical technique that helps us find the best fitting line through scattered data points. It's the foundation of modern regression analyses, the statistical tool that underlies everything from economic forecasting to medical research. Francis Galton discovered correlation and regression toward the mean, concepts so fundamental to modern statistics that it's impossible to imagine data science without them. But here is where our investigation uncovers something uncomfortable, something that every modern data scientist must confront. This bloodline isn't pure. Part 2: The Dark Heritage. Galton, brilliant as he was, became obsessed with using statistical methods to promote what he called eugenics, the pseudoscientific belief that society could be improved by controlling human breeding. He believed statistical measurements could identify superior and inferior human beings, and his work provided intellectual cover for some of the darkest chapters in human history. This isn't ancient history relegated to dusty academic footnotes. The same statistical methods that power modern AI were weaponized throughout the 20th century with devastating consequences. IQ tests were designed to exclude immigrants from certain countries. Redlining algorithms systematically denied mortgages to African American families. Credit scoring systems perpetuated racial and economic discrimination for decades. The tools themselves were not evil. Mathematics is morally neutral, but the people wielding these tools were biased. They had assumptions and agendas, and those human flaws got baked into the systems, codified into algorithms, and amplified at scale. This is the uncomfortable inheritance that every data scientist carries. Their work is not morally neutral. Every algorithm embeds the assumptions and biases of its creators. Every data set reflects the inequalities and prejudices of the world that generated it. The same techniques that can cure diseases can also perpetuate discrimination. The same insights that can optimize supply chains can also enable surveillance states. Modern data science, as most people understand it, however, crystallized around a very specific moment that most people remember as just a baseball story. They are wrong. Part 3: The Moneyball Moment. Michael Lewis's Moneyball and its Hollywood adaptation starring Brad Pitt told the story of Billy Beane and the Oakland Athletics, but that was just the surface narrative. The deeper story was about a revolution in thinking that would ripple across every industry and ultimately reshape how we understood decision making itself. Billy Beane and his analyst, Paul DiBodesta, weren't just changing baseball. They were proving that statistical analyses could systematically outperform human intuition, even when that intuition was backed by decades of professional experience and millions of dollars in scouting resources. The Oakland A's, operating with one of the smallest budgets in Major League Baseball, used data science to compete with teams that spent 3 times as much on player salaries. The Moneyball revolution revealed 3 profound truths that would become the foundational principles of the data science age. First, conventional wisdom is often spectacularly wrong. Second, insights matter more than resources. Third, human intuition, no matter how experienced or confident, is systematically biased in predictable ways. These weren't just baseball insights. They were universal principles that could be applied anywhere humans made complex decisions based on incomplete information, which is to say, everywhere. Wall Street firms started hiring statisticians instead of just MBAs. Retailers began using data to optimize everything from inventory management to store layouts. Marketing departments discovered they could predict customer behavior with greater accuracy than focus groups ever provided. Police departments started using predictive analytics to allocate patrol resources. Hospitals began using data science to reduce readmission rates and identify patients at risk for complications. But perhaps no organization understood the broader implications of the Moneyball philosophy better than a secretive company founded in the shadow of Stanford University. Part 4: The Palantir Connection. Peter Thiel, Palantir's co founder, had already proven the power of data networks' effects as an early investor in Facebook and PayPal. He understood that in data rich environments, information advantages create winner take all markets. Platforms became more valuable as they collect more data, which attracts more users, which generates more data, creating an unstoppable feedback loop. Palantir took this concept and applied it to intelligence gathering, creating tools that could integrate and analyze data from thousands of sources simultaneously. While other companies were using data science to sell more products or optimize operations, Palantir's founders realized that information advantage could be the ultimate competitive advantage in any domain. Their data scientists weren't just building predictive models, they were creating what military strategists call information dominance, the ability to see and understand complex situations better than anyone else in the room. Whether it's tracking financial crime networks, optimizing disaster response, identifying security threats, or mapping the social connections of terrorist organizations, Palantir systems demonstrate the ultimate potential of data science: the power to impose order on chaos, to find signal in overwhelming noise, to predict the seemingly unpredictable. This is why data scientists have become so crucial and why their demand continues to skyrocket despite economic uncertainty. In a world where information has become the most valuable resource, they are the master craftsmen. They don't just use tools, they forge new ones. They don't just analyze data, they transform it into intelligence, insight, and ultimately influence. The rise of these modern alchemists represents more than just a hot job market or a trendy career path. It represents a fundamental shift in how power operates in the 21st century. We're witnessing the emergence of a new kind of authority, algorithmic authority, where decisions that affect millions of people are made not by elected officials or traditional institutions, but by mathematical models built by people most of us have never heard of. Understanding their rise is just the beginning of our investigation. To truly grasp their influence, we need to venture deeper past the mythology and into the engine room where the real work happens. We need to see how the sausage gets made, understand the tools of the trade, and confront the uncomfortable realities that come with this much power operating in the shadows. Because once you understand how data science actually works, the methods, the models, the inevitable controversies, you'll never look at a recommendation, a search result, or an algorithmic decision the same way again. The question isn't whether these systems are influencing your life. The question is, do you want to understand how? Next time on the Gray Files, we're going behind the curtain, into the engine room, where digital alchemy happens. We'll explore the tools that transform data into decisions, the methods that find patterns in chaos, and the growing list of things that can go catastrophically wrong when algorithms meet the messy reality of human behavior.